Welcome back. We have come so far and we have learned a variety of things about inventory, starting from the basic concepts to building models to creating stochastic models, then learning about DES, discrete event simulation, then using SymPy package to build actual real-world stochastic simulations. In this particular lecture, I would like to put all of those things together to create an actual real-world simulation using DES, discrete event simulation techniques. And before applying the concepts into code, I want to discuss our main approach prior to writing the code, how we would go about thinking about the solution for the problem of simulation of our real world or our actual inventory or items for which we want to simulate the inventory for optimization for enhancing our business. So we have learned that DES operates by simulating events that change the state of the system. Time advances only when an event occurs, making it efficient for modeling systems with intermittent activities, like for example inventory system. We have also seen the workflow for how these simulations work. We always start with creating the first SymPy environment object, which manages the simulation timeline and events. So for example, sub-processes like handling of the demand using generators, which we have seen earlier, and handling of orders using generators can be set up in the main process itself. So for example, we can set up triggers which will check the state of the inventory to generate the order generation scheme or the sub-process. And then we will start to model our variables such as inventory levels, costs, and stockouts using data structures inside the simulation classes. The state of the system can be represented by variables such as inventory levels, costs, and stockouts, and these variables will be updated as the events occur. Next up, we can keep track of these metrics using some sort of data structures like lists, arrays, dictionaries, and so on, and other plain old Python objects for these purposes. So then these observation classes can then be used in the visualization scheme to check how does our stochastic inventory change over the period of time. Finally, we must also understand that since we will be using a lot of generators, DES models will use concurrency to interact these generators with each other, such as customer demand and order arrivals. Then we can look at into using what kind of distributions we want to use for our stochastic or random natured variables. For example, what sort of lead time model which we would like to use. And finally, we would be able to record the performance metrics and analysis of our inventory. So let's look at what basically this whole code will generate. So at the end of this, basically, we will be generating a dashboard for our simulation. So we will be running the simulation for, let's say, a period of 1 year, or let's say a period of 360 cycles. And we will be generating KPIs such as the one shown on the screen, so service level, total cost, number of orders, and so on. Then we will be generating the stochastic visualizations, for example, how the inventory level changes over a period of time. And in this particular case, I'm using Plotly. I'm using Plotly to create these visualizations, which is a similar package to Matplotlib, which we have seen earlier. And then amongst other things, we will also be plotting the distributions of demand, the line distributions or the demand patterns over the period of time, and also the costs of our inventory of the cycle of how our item cost can be managed properly. And then among other things, some other order patterns and the service level which has been achieved using the base inventory parameters, as well as it will also calculate the optimal reorder point and this can be used to optimize our particular item. And these visualizations are very similar to other business intelligence applications which are used to show the impact of various parameters on the inventory itself. So now let's take a look at the code itself. So the overall code is basically divided into two parts. So the first part is basically the simulation part, which runs the simulation, and the next part is actually which is basically constructing this dashboard. So I will go over the first part in greater detail, since the second part is more to do with creating this Tableau-like business intelligence dashboard, the details of which are outside the bounds of the course. However, I will tell you this, that we will basically generate observation objects, we will generate objects, lists, dictionaries, which we would then insert into these visualization classes, and we would use the plotty methods for this particular library, which have been imported here, to plot various kind of charts and visualizations that we are basically seeing in this part here. So now let's look at the simulation part of this program. Now for the simulation part, I will once again explain the core aspects of it. So we have this whole block, which is basically a giant data class. So as I explained, data class is just used to store inventory system parameters with type hints. And then we have this particular data class, or the cluster of different inventory metrics, which will be used to run this particular simulation. So for example, we have our reorder level, quantity, purchase cost, selling price, holding cost, and all the things which you have seen so far. Next up, this is our main class, which will take these two bunch of classes and then apply methods on them. So for example, this will be our initialization block, where we are initializing the simulation parameters for this particular environment. And once again, the idea of using classes is it's a data structure where we can club our methods and our variables and maintain the state of those variables, as well as use encapsulation techniques for more effective programming. And in this block, for the initialization of the class, we have things like inventory, track, and this number ordered quantity, which tracks the quantity on order but not yet delivered. We have the metrics variable, which is basically taking from the outside data class here. And then we have the optimal reorder point and the safety stock. Then we have our processes for demand generation and observations. And next up, we will define a series of functions which we have seen earlier, like calculation of safety stock, calculation of reorder point, demand generation, generation of lead time, which follows the same models which we have seen earlier. And then we start to create our main generators or main subprocesses, like handling of the orders. This is basically a generator for handling inventory orders. So once the orders are triggered at the reorder point, this particular function or generator will take action, and here we are basically logging the events as they occur in the simulation into the metrics object, which we can then use to build visualization, since it is basically a dictionary of each of these generator outputs over the period of simulation. And the other aspects of it is that we apply cost for the order, we wait for the lead time before order arrival, and then we receive the order and update the inventory. Then we have the observation class or observation function, which is basically just a logger function to log the details of different metrics and variables running during the course of simulation. And then moving forward, we have our demand generator. Once again, a demand generator function to simulate customer demand. And this function will once again generate demand. It will fulfill the demand if the inventory is sufficient. And then it will handle stock outs if demand exceeds the inventory. As well as we will also add the reorder checking condition and trigger order if required. And then moving forward, we have our function to calculate the statistics of the inventory when it's running during the event, during the simulation itself. So once again, we have our key parameters such as average inventory, service level, average demand, and so on. And these will basically return our statistics object, which we will use at the output screen to see the results of our simulation. So once we finish this part, then this is the printing function, which prints out all the details based on the logger function, as well as this particular calculate statistics function. And this particular function will be used later on to create the charts and visualizations using this below class. So now we have seen all the parts of this particular class for inventory simulation, and we can run our example, for example, for a particular item. So we have, let's say, at the start a reorder level, a reorder quantity, a purchase cost, and a selling price, as well as the holding cost, lead time average, lead time standard deviation, demand average, demand standard deviation, and the service level required. So these will be entered in the inventory parameters class, which we have seen earlier in this part of our code. So once we create that, we'll pass on those parameter objects or class into this particular enhanced inventory simulation class for running and setting up of the inventory. And the results will be something like this. So for example, this was our demand model, which we have set up based on the normal distribution, which is basically shown in this part here, which is this particular part. So we can actually use a different distribution or a different model if it is more in line with our actual data. Now coming back, amongst other things, we will have our lead time model, which we have set up here as a normal distribution model with a mean of 5 and a standard deviation of 1. This is our safety stock analysis. So we are achieving a service level of 54.24% based on these parameters which we have added. And this is our reorder point analysis. So the optimal reorder point which have been calculated based on the simulation is this one. And let's say currently our reorder point is 100, so we will change it based on this particular output. And this is the inventory performance and the cost analysis of this particular simulation. So once we have created this simulation, we have inputted our parameters for the items, we have run the simulation, we have generated results. The next part is obviously to plot this visualizations and create a dashboard for it, which can be presented to the relevant stakeholders, let's say for decision making. And once again, we will be using plotly and matplotlib libraries to create these plots. And to create these plots, basically we'll go one by one on each kind of plots we want to create. So be it a line chart, a bar chart, a KPI chart, we have to take the right object or the right object from the inventory simulation and then use it with the plotly API to create the visualizations.